Okay, for 21, if this is an exam question, I'd look at this and say, they want me to prove this. They're actually giving me a very good hint that this was done by integration by parts, right? With the understanding, looking at it. Yeah, and again, you might make mistakes, but you can always erase what you've written down and say, I'll try again. So I'm going to say, kind of looking at it, I'm going to say it looks like the u is x to the n. That means du would equal n times x to the n minus 1. And it looks like the dv is, again, if I took xn equals the u, it would be e to the x dx. And that means v equals e to the x. All right, so you're going to look at this over here, and you're basically just doing integration by parts right now. So I'll pull this over here. And what do you get? You get uv, which is x to the n, e to the x. We'll compare this with what they say it should be, minus, it's going to be v du now. So e to the x, and du is n times, I'm pulling any outside because it's a constant, or I should say a parameter, nothing to do with x at this point, x to the n minus 1. Give me 1 second. I forgot to write the dx over here. I just noticed that, and I'll write it over here. You may wonder why I noticed that, because it just did make sense when I wrote that down. Let's look at it. Did we prove that by using integration by parts? And we're using integration by parts, all right? Are we getting what we expected to get? Let's take a look. X to the n, e to the x, minus n. A little different order in the multiplication, but that doesn't matter because multiplication is e to the x. Yeah, it works beautifully. How do we do that? Integration by parts. We put our parts down, and we did our integrations, and we actually just proved it. Thank you.